Hello, this is Ashwin. Today I'm presenting my EDA project, Explanatory Data Analysis project on Netflix, TV shows and movies. The tools and libraries that I have used in this project are NumPy, Pandas, Seaborn, Matplotlib and Plotly. So let's get into the details. I'll share my screen. So let's firstly discuss about the project summary. In this EDA project, we focus mainly on Netflix movies and TV shows datasets. It's aimed to extract meaningful insights and identify patterns in the platform content over time. The dataset includes over 7,700 entries and features attributes like title, type, country, release year, date added, rating, and genre. Using UBM, Univariate, Bivariate, and Multivariate approach, the analysis explores various dimensions such as content type distribution, geographical distribution, genre popularity, and trends over time. This is my GitHub link, and let's discuss about the problem statement. The problem statement is to analyze the Netflix content data to uncover trends and insights about content type, popularity by region, genre distribution, and user engagement patterns based on ratings and release years. So the main business objective of this EDA project is to guide Netflix in making data-driven decisions for content acquisition, regional expansion, and platform personalization by analyzing patterns in movies or TV content, additions, genres, ratings, and user preferred content formats over time. So these are some of the general guidelines. So let's begin our EDA. Firstly, let's know our data. The important libraries that I've used in this project are Pandas, NumPy, Matplotlib, Seaborn, and Plotly. So let's run this first. Yes, done. So firstly let's load our data. Netflix movies and TV shows dataset. So let's run this. So let's see the first look of the dataset. You can see the different types of columns available in the dataset are short ID, type, title, director, cast, country, data, release year, rating, duration, list, and descriptions. So let's see the how many rows and columns available in this dataset. By using Netflix data shape, you can see there are 7,787 rows and 12 columns available in this Netflix dataset. Let's see the detailed information about the dataset by using Netflix data.info. You can see the different types of columns and how many is there in null values present in our dataset. Let's see. Yes, we can see the null values present in the director table, cast, country, and there are some of the other ratings. So let's see the duplicate values present in our dataset by using Netflix data duplicate dot sum of. There is no duplicates present in our dataset. Let's see the missing values or null values are present in dataset. By using this, I have created missing values sum and the percentage of missing values. Let's run this. We can see the missing values count, sum of missing values count, and the percentage of missing values. You can see the director's missing count and the percentage, cast, country, data added, rating. So let's visualize these missing values by using heat map. You can see the missing values present in the director, cast, country, the ratings. So what did you know about your data set? We have seen that this data set contains over 7,700 entries with 12 features, 12 columns, and the missing values exist in fields like director, cast, country, data added, and rating. The most content is from US and between 2015 and 2020. So let's understand our variables. So by using Netflix.columns, let's see what are the columns available in our dataset. The show ID, type, title, we have seen this before. So let's describe our dataset. In this dataset, only the numerical column which is available is the release year, and the variable descriptions are type, movies or TV shows, the title, name of the content, director or cast, people involved, the country, production country, the date added when it was added to the Netflix, and the rating, age ratings, the duration, length in minutes or number of seasons available, genre, category or genres listed. Let's check about the unique values in each variables. You can see the unique values present in our data set in the each column. Let's proceed to the data wrangling or the data cleaning part in our EDA project. So first of all, I have created the copy of the dataset. We successfully copied the dataset. So let's handle the missing values here. Now I have created, I've used the columns such as director, caste, country, as there are, you can see the percentage of the missing values. It's 30%, 9%, 6%. So some of the data that these are categorical data. So I've used filled with unknown values, and the data and rating, these are so minimal amount of data, it's 0.1%, 0.2%. So I have dropped those rows. So let's run this. Yes, done. Let's see, is there any null values presenting after handling the missing values. You can see there are no missing values present in our data set. So let's extract numeric movie durations. I have created duration integer and duration type columns, and convert this as float type, and this is a string type. Let's run this. Now I have converted date added to date time and created year and month columns. You can see I have created date added. I have converted date added to date time type, and I have created two new columns, year added and month added. So let's run this. Let's see what we have done till now by using copy.head of. You can see we have created new columns, duration integer, duration type, year added and month columns, and we have updated our missing values by using unknown values. So now let's identify the outliers detection for the movie durations. You can see the number of movie duration outliers are 336. So these are maybe which has series or episodes which contain 6 episodes, 10 episodes. That the movie durations are about 200, 300 minutes, 400 minutes. So I will not remove these outliers. I will just flag these outliers. Done. Let's see the outliers data. So I created a column is outlier duration. You can see is outlier duration. These are the outlier duration columns. You can see the duration is 4 seasons, 1 season, 1 season, season. So these are the outliers. Let's see about the final rows and columns after handling missing values after the data wrangling. You can see the final rows 7770 and the columns are 17. As we have added some of the new columns, the final data set looks like this with the new columns. So what manipulations we have done and insights you found. Let's see. Converted data to date time format, extracted year and month from data added, and dropped missing or null values wherever necessary, and detected outliers and flagged the outliers. So let's get into the data visualization storytelling part with the charts. So I have used in this UBM approach, univariate visualization, bivariate visualization, multivariate visualizations. Firstly, let's get into the univariate visualizations. The chart one, the content type count. In this I have used type column. Let's run this column and see. You can see in the Netflix the content is more about the movies, almost 70%, and TV shows are 30.9%. Why did you pick the specific chart? Is to show the overall share of the movies versus TV shows. The insights are 70% of the Netflix content is movies and 30% is TV shows. And let's see the impact, and is there a negative growth impact? Yes, it helps in understanding the platform's main content format. And is there a negative growth? No. Movie dominance is consistent with demand trends, as more people tend to watch movies, so the demand is high for the movies. And chart 2, the top 10 countries with most content available by using this data set, the country column. Let's run this. These are the top 10 countries with most content. Why did you pick the specific charts? To find the countries with the most content, and there is inside USA dominates, followed by India and UK, USA, India and UK, and Is there any impact and negative growth? Yes, highlights strong production regions, useful for regional marketing and localization strategies. And there is no negative growth. Emphasis is global content strength. And let's get into the chart 3. In this, I have used counterplot. The column that I have used in this are year added. Let's see. You can see the different content with the TV shows or movies added in the Netflix, in which year the content is added, uh, to track the growth of the content over time. So that's why I have used this chart. And the insights are the Netflix content peaked between 2018 and 2020. You can see the 3 years the Netflix content has peaked. And is there the impact helps analyze content expansion trends and growing user bases. Is there new to growth? Slight dip post 2020 could reflect saturation or COVID-19 disruptions. You can see the drop in 2021. That's maybe cause of COVID. And let's go to the chart for the rating distribution. In this, I have used a rating column. So let's run this. How the rating is distributed. You can see the different types of ratings, TV, MA, TV14, TV, PJ. These are the different types of ratings. Is to analyze content content rating spread, and the insights are TV, MA, and TV14 dominates. TV, MA, and TV14 dominates the ratings, and insights are the impact indicating strong engagement with mature and teen audiences. And coming to the chart 5, the top genres available in this dataset, and this the Netflix TVs and movies. Let's see, used in this listed in column. Let's run this column and see the output. You can see the top 10 genres. International movies, dramas, comedies are the top 3 genres present. To identify the genre popularity, the insights are international movies, dramas, and comedies are the top genres, as you can see in the chart. And the impact helps decide what type of content to acquire more. There is negative growth, no. Validate user preferences. So let's we have finished the univariate analysis. Let's discuss about bivariate analysis. In this, I have used type process rating. The column that I have used are rating and the type columns for this. Let's see the visualization. You can see the pink color shows the TV shows and green color shows the movies. And to compare the content type by rating, insights, TV shows and movies are more common in teen ratings. And is there the impact is guides platforms rating strategy, and is negative growth, no. Supports audience alignment. And coming to the chart 7, content type versus country, the top 10 countries. Let's see, I have used in this column the country column and the type column. Let's run this column and see the visualization. You can see the top 10 countries, content type by top 10 countries. You can see United States, Egypt, and India are the top 3 countries. Let's see, why did you pick the specific chart? To export the country-wise preferences. And the insights are, India shows more movies, US has more balance. You can see India shows more movies and US has balance, whether it may be TV shows or movies. Is there any the impact original content expansion ideas of strategies? Negative growth, no. Enables better localizations. And coming to the chart 8, it's a release year versus content type. The columns that I have used is year added, and the type columns. Let's run this and see the visualization. You can see the content type by release year. Why did you pick the specific chart? To the time trends for content type. Insights, growth of TV shows faster after 2016. You can see the growth of TV shows, and with the TV shows or movies, the growth is higher compared to the 2015 or below years. And the impact is shows changing content strategies, and negative growth requires evaluation of market saturations. Now let's discuss about the multivariate visualizations. In this, I have used year added and type columns. So let's run this visualization and see the output. You can see how the Netflix content growth over years by using this plot. Why did you pick the specific chart? Tracks the growth over movies and TV shows added to the Netflix over time. And the insights are both categories show steady growth, but movies begins increasing more rapidly after 2016, indicate a strategic pivot towards the serialized content. You can see after 2016 the movies are increased more compared to the TV shows, and the impact or understanding this trend can help Netflix anticipation future demand and balance its content investments accordingly. And coming to the last chart, it was a genre by rating was a step. The column that I have used in this are the rating, duration, integer type columns. So let's run this and see the output. So the visualization, you can see you can see the movie duration by rating, uh, you know uh, combining genre, content rating and content count. The insights are the dramas and comedies dominates across multiple ratings, and family friendly genres like children and families are underrepresented. And the impact are supports continued investments in high demand genres like drama, and reveals underutilized genres like its content for expansion. And is there any negative growth? That chart shows that the significant portion of popular genres falls under TV, and R ratings. So these are the different types of visualizations or charts I've used in this Netflix TV shows and movies EDA project. Let's see the solution to the business objective. We can see the focus more on growing TV shows content for youth, TV 14 and TV MA ratings, acquire region specific content like India, UK, invest in top genres like drama, comedy, action, and track year-wise performance to predict the content demand. Let's see the conclusion of this analysis. This video revealed valuable patterns in content type, country contributions, genre popularity, and yearly trends. And the Netflix can use these insights to align its content strategy with viewer preferences and regional demand. So that's my EDA project. Uh, Thank you. This is Ashwin.